Globules of Reactions by Lucas Hong and Sarah Hatcher. If water temperature is lower or higher, will the tablet change the speed of dissolvement? The hypothesis is if the water temperature is higher, then it will dissolve the tablet faster because the water molecules move faster heated. The variables and controls. Manipulated is the water temperature. The responding is time of reaction. Constant is the brand of fizzing tablet, material of container, and amount of water. The control was the room temperature water experiment. For materials, we used 4 cups of water, fire or water heater, ice, cups, fizzing tablet, thermometer for food, refrigerator or water cooler, and a timer. For the procedure, we separated 4 cups of water. 1 cup we put in the refrigerator, another cup we put it to heat, another we left it on the counter so it will get in the room temperature, and the 4th cup we added some ice. So you can start with any of the waters that you prefer and measure the water temperature. So open a tablet and drop it in the water and start the timer simultaneously. If you don't start the timer as soon as the tablet hits the water, then it won't be accurate. So stop the timer once you can't hear or see new bubbles forming. If you don't stop the timer exactly when you can't hear or see bubbles forming, the experiment also won't be accurate. So then you can repeat for the other cups. Background research. The temperature of water affects the movement of molecules, and the hotter water makes molecules move faster. To change the rate of chemical reactions, you can change the reactant size or increase the surface area of reactants. To measure the rate of change in an experiment, you can change variables and change how the reaction occurs and how it can be measured. When 2 or more molecules interact with each other and the molecules changes, that is a chemical reaction. A chemical reaction can have different types of atoms, like ions, compounds, or molecules of a single element. The blue bar right here has room temperature. Orange has hot temperature, the gray bar has cold temperature water, and the iced water. In the end, you can change the rate of chemical reactions if you change the right thing. Our hypothesis was correct. Our data showed that the hotter the water is, the faster it dissolves the tablet. We got these results due to the water temperature affecting the molecule movements, and the hotter the water was, the tablet dissolved quicker. Some errors that occurred in the project was that we couldn't do a lot of attempts of a project and gave us accurate results. Also, we only tested it on water. We could also have tested it on juice and other beverages. Some ways to improve this project is to use real chemicals to make chemical reactions and find different ways to change the outcome of the experiment. These pictures are for colder experiment. They are all a little bit foggy and they have some bubbles in it still. The hotter experiment weren't so foggy, and they didn't have so much leftover bubbles. As soon as the tablet dissolved, the bubbles also kind of went away.